Now let's look at example 3. Now example 3 is very much the same as example 2 before it. It just requires a little bit more work. So we are continuing to work backwards. We're trying to find the angle like we did in example 2. Instead of the little theta symbol, we've now replaced it with an x. Same thing. And we're going to do a couple of steps because we need to get this sine of x alone. So the first thing we're going to need to do, and it looks odd, is we're going to need to move the square root 3 over. And that's just a number, so we'll add it. So we have 2 sine of x. I usually like to put brackets around it, but I don't always. You don't have to. And then from there, we need to get the sine alone, so we'll divide both sides by 2. So these 2's will cancel out. So I have sine of x equals a root 3 over 2. Now, it is worth noting that it is a positive root 3 over 2. So let's keep that in mind. And just like over here, we're going to find out the missing angle, or 2 angles, that make this statement work. So that's what we're looking for. So sine is positive in 2 quadrants, but maybe we should first take a look at the reference angle. So root 3 over 2 for sine. Sine is on the right-hand side. Root 3 over 2 is up here, which means we're looking at a reference angle of 60 degrees. So I'll write that down. A reference angle of 60 degrees. Now, sine is positive in 2 quadrants. It's positive in the all are positive, and it's positive in the sine's positive. So those are the 2 angles that I'm going to have. So let's take a look here. My reference angle was 60. Well, it's a bad drawing. I should probably have a slightly bigger. 60 looks a little larger like that. So we know this angle is going to be 60 degrees, and we know over here it's also going to be 60 degrees. So what is our actual angle? And the same with this side. What is our actual angle? That's what I want to know. So this is 0. So 0 degrees plus 60 means our answer here would be 60 degrees. And this one's 180. Now we're not quite at 180. We're 60 shy of that. So we're at 120 degrees. Therefore, we can send this down here. X is equal to 60 degrees or 120. So it's not very much, not very different from the previous questions. Not by very much. It just requires me to move over the root 3 and divide by 2. So just a little bit of algebra. I'll just zoom out here in case you need to take a look at that. But I will move on to B now. Oops. Again, remember I need to get this alone. That's the whole point. So I'm going to subtract this root 3 because it is being added. So I'll do the opposite. I'll subtract. And that's it. I've already gotten it alone. Tan of x is a alone. Now I don't know the reference angle for this. So when is tan root 3? So I guess root 3 over 1. Now that's when it's sine over cos, which is the right side over the left side, which I've already done here. So this one over this one, it's 60 degrees again, because I get you root 3 over 1, which is just root 3. So it is 60 degrees. Tangent, remember, was in green, so it's the green one, root 3. So it's 60 degrees. Same as letter A there. Now tangent is negative. Okay, I need to figure out where is it negative. So C-A-S-T. I know it's positive here, so it's not that. And I know it's positive here, so it's not that. It would be negative in this quadrant, and it would be negative in this quadrant here. So I'll just erase these. I know those are the 2 quadrants, and I know that this gap is 60 degrees between the terminal arm and this x-axis, and between this terminal arm and the x-axis, like this. And I know that gap is 60 degrees. So the question then becomes, well, what is that? And what is this? Now this one we actually already did. This is 180. And we're not quite there. We're 60 shy. So it would be 120 degrees. And the same would be true over here. And this would be 360, but I'm 60 shy. So I must be at 300. Therefore, you can have a sentence. Therefore, our x is equal to 120 degrees and 300 degrees. So I'll zoom out. Again, not much is different with letter B as well. I just have to subtract the square root of 3 over to the right-hand side. Now for my favorite question, letter C. I'm going to add this 2 over to the right. So I get 4 cos squared of x is equal to 2. And then I'm going to divide by 4. So cos squared of x is equal to 2 over 4. Now you might want to reduce that to 1 over 2. I'm actually not. And the reason is because I can see that I've got a square and I need a square root. So I need a square root, and the square root of 4 is a really nice number. So that's the only reason. If it was a 9, like if it was a 3 over 9, I wouldn't reduce it either, because I know, the square root of 9, that's a perfect number. So that's why I'm not square rooting it. If it was like a 5 or a 6 over 16, I wouldn't reduce this 6 over 16, even though I know it's 3 over 8. I wouldn't do that because I know the square root would be a nice number. So the square and the square root will cancel, leaving me with cos of x. Now remember, square roots get you a plus or minus, so I'm going to do a plus or minus there. If you ever square root a square when you're solving, don't forget the positive and negative. Now the square root of 2, well, that's just the square root of 2. And this is the square root of 4. So I just did them separately. Now the square root of 2, I don't know what that is, but the square root of 4 is just 2. So now I'm looking for a reference angle where it's root 2 over 2. And for cosine, so cos is on the left, and root 2 over 2 is right here. In fact, they both should be root 2 over 2. It's right here, and that is 45 degrees. So we have 45 degrees is our reference angle. Now usually you're asking yourself, okay, well, when is cos positive or when is cos negative? But here it's both positive and negative. So you can say, well, it's going to be positive here in these two quadrants, and cos is negative in these two. So I actually want all of the angles. And that's why I like this question so much. That only ever happens if you're square rooting to get rid of a square in the solving one. So we're going to have an angle in every single one. All of these where the terminal arm meets the x-axis are 45. Terminal arm, x-axis. Terminal arm, x-axis. Terminal arm, x-axis. They're all 45 degrees, so I need to find out all of these. So this is 0 degrees, or 360. And this one right here is, it's going to write 45, it's 180. So this one right here, well, this is 180, but we're shy by 45. So this would probably be 135, because that would get you 180. This is 180 plus an additional 45, which is 225. This angle right here would go all the way around like that. Well, it's not quite 360, it's 45 short, so it's actually 315. That's 45 short. And this one, well, that's just from here to here. That just moves only 45 degrees. So you get all of the angles. So you can have a little therefore sentence. Therefore, x can be 45 degrees, 135, 225, and 315. Now keep in mind, for all of these questions, we only ever go to 315. We only ever go one time around. I guess you could say, if you wanted to, let's go around a bunch of times and then land here. And that would be a true answer. But that would be a number that's like 360, another 360, and then 315. That would be a huge number. And this is telling us, and this is why this is always written, it always says keep it less than 360. So don't go around more than once. Just go around the bare minimum. Don't go backwards. Just go in the positive direction once at max. So I'll zoom out here if you need to zoom. Zoom out, and you can pause it and write anything down. But we will move on to the next chapter after this.